Voilà con cagnapo para tuale che lesce looking at the operation ya crusher. The composition here is such that to get the lubrication system, then the main drive, and then the vibrators, and of course the hydroset. Number four, to that all the identified inputs and outputs, we're going to map them onto FactoryIO so that we're better able to simulate the circuit or the logic with the help of FactoryIO. Now, effectively, it's not the only way we simulate the program that we have created so far. Any other method which you think is easier for you, but the method to allow to appreciate the usability of FactoryIO to help us simulate the output. Okay, so we can make use of an indicator light. Okay, if not, do we have lights? Maybe. Let's see, what do we have? Operator stations, light load part stations, warning devices. Let's see. Oh, let's look for pilot lights. Indicator light green. So running, we can pick red. Okay, we can maybe pick red for running. So indicator light red, this one right here is going to be 4DC1. So this is for 4DC1. Okay, so we've taken care of 4DC1. Then lubrication pump fault status is 4DH1. Okay, so for faulted state, yellow. Okay, so for a faulted state, maybe we can use yellow. Okay, so for a faulted state, we use yellow. If the loop pump has got a fault, then the yellow indicator lamp is like going to come on. This right here is going to be 4DH1. Okay, this is going to be 4DH1. So 4DH1. This is 4DH1, and thereafter lubrication pump status running. So running is going to be okay, it's supposed to be green. The only thing here is when 4DC1 is energized in our logic, so this lamp here 4DC1 is supposed to come on, which is going to serve the same purpose as us saying lubrication pump running by way of 4DH2. Okay, so we're not really going to bother with 4DH2. We're just going to focus on 4DC1 because of course we're using a my indicator lamp, so we've already taken care of the lubrication pump running by way of this guy indicator lamp 4DC1 coming on. The main drive control and the main drive status faulted. Okay, so we just need to AD1, and then we're going to need to AH1. Okay, so essentially we can just copy these. Okay, you can just copy this one here and then this one there. So So this one is going to be 281. It's going to be 281, and then this other one is going to be 2AH1. Okay, it's going to be 2AH1, like so. So that covers all the reference points that we're going to need to simulate the operation of the lubrication system, now operation of the crusher main drive motor. Okay, so that's what we've done. So at this point we're done with this panel. So this panel is just going to do with the loop system and the crusher main drive. So everything to do with the loop system and the crusher main drive is going to be on this panel. So the next part is going to be with the hydroset. Okay, so just to simplify things, I'm just going to copy this whole arrangement, okay, like so. And then in this regard, we're not going to be needing the siren. So this is what we have. So with the hydroset, what we need is the hydroset raise, hydroset lower, and hydroset alarm cancel, which is a toggle switch. Okay, so to do this, what we need is to change the labels. Okay, momentary to momentary push patterns. Okay, we can get rid of this one here, then we can copy this so that this one becomes, okay, let me just copy this so that we don't waste time with this. Okay, so the first one is going to be hydroset raise, then this other one is going to be hydroset lower. Okay, it's going to be hydroset lower, so which takes care of the first two. And then of course we need the hydroset alarm cancel as a toggle switch. So clearly you see that on this panel we don't need the reset. Okay, I don't really think we need the reset. We don't need the reset. Nope. So we don't need the reset on the hydroset panel, but what we do need is the toggle switch, which is this one here. So I'm going to just move it up. So position 1 we're going to use for hydroset alarm cancel. Okay, so Control C, select the state 1. Okay, so this is going to be hydroset alarm cancel. Select the state 2. This is not really going to be of use. Okay, can I trade this for something else? Okay, configuration, maybe 2 position. I think this will be better suited to what we're doing. And then of course select the state 0. We're not going to associate anything with this, but select the state. Then do we have the operation configuration, 2 positions? Okay, nothing on 0. And then this one is going to be position state 1. Select the switch to state 1. This is hydroset alarm cancel, so HSC. Oh, that takes care of hydroset alarm cancel. And then on the hydroset protection inputs, how many of these do we need? Okay, clearly we don't need a whole lot of inputs for the hydroset, so we can safely get rid of what we don't need. Okay, then maybe move this down a bit. Why don't you want to move? this down a bit, like so. Then of course we're talking about the protection inputs. Okay, so let's get rid of this one so that we put all the protection inputs in one single line. We don't need this selector switch, we don't need this, we don't need that, we don't need this, we don't need that, but rather protection inputs. These ones here, we need a hydro set pressure switch. We need this one here, Control C. So this becomes this here. Which becomes this one right there. I want you to have a clear view of the label, okay? And then the next protection inputs relating to the hydroset is 4CE3PI. So let's copy this, assign it to this push button, okay? Then 4CE2PI, we'll get this, assign it to that, then delete what we don't need, okay? Because we're done with the protection input, so all the other emergency push buttons are now redundant. We'll come and add them if we need them, but for now we don't need them, right? Do we need to make some adjustments in terms of housekeeping? We're talking about mapping the outputs now, okay? So there's hydroset raise control. Okay, so first level, second, third level. So clearly we're here, okay? So we need to just map 4cc1. Okay, we need to map 4cc1. Maybe I'll so 4cc1. This is 4cc1, like so. And then we also need 4cc2. So when these are running, this indicator lamp turns red, okay? So this becomes 4cc2, like so. And then solenoid valve control, when running or when it's on, it's going to be red for running, okay? So this becomes SVC, like so. And then what else do we have now? Okay, hydroset faulted indication, we're using the yellow indicator light, okay? Hydroset faulted indication. So this is 4CH1. So this now becomes 4CH1. So hydroset faulted indication, then there's the hydroset on. We're not going to really talk about the hydroset on because we're using indicator lamps to represent the control of the hydroset, because 4cc1 and 4cc2 drive the hydroset in the upward or downward direction. So these indicator lamps will be sufficient, okay? And then of course we're talking the hydroset low pressure switch. Perhaps I was a little bit too hasty in deleting the siren, okay? So I'm going to borrow this. And then this one here is the hydroset low pressure siren. Hydroset low pressure siren, like so. Hydroset low pressure siren. which takes care of it. And then hydroset OK. This can just as well be indicator lamps. Okay, there needs to be green. The OK indicator lamp should be green and the faulted state should be red. So let me just copy this. Then this is HDR fault. Okay, HDR FLT to represent the hydroset fault. Do we have some configurable parameters? Apparently not. Do we have a green indicator lamp? Nope. So we need an indicator lamp which is green. So start push button, that's not what we need. We need a green indicator, pilot light or light indicator or indicator lamp if you want. Need to put it right on the face of this, in that position. This is HDR OK. Okay. Oh, come on. So HDR OK, that's taken care of. So we've done HDR OK, HDR fault, and then we've done 4CH1, or rather we've done 4CC1, we've done 4CC1, 4CC2, SVC, which is this one here. We've done SVC, and then we've done 4CH1 as hydroset status faulted. Okay, and then we still have some 2 indicator lamps. We don't need these 2. Okay, and then of course we've also done the hydroset low pressure siren, which is on the top of the control box. Okay, so which is on top here as the hydroset low pressure siren. So we've done the alignment for the hydroset, and thereafter we're talking about vibrator number 1. In relation to this, we're talking about the inputs, normal inputs, and then protection inputs, and then output mapping for vibrator number 1. So what we will do is this. Okay, we'll copy this one here, we'll copy that one there. We don't need the siren. Okay, but what we do need, we need basically the 3 position selector switch as vibrator 1 select and vibrator number 2 select. So the first thing we need in our little perfect world is a multi-position selector switch, and we just need 1, we don't need 2. And then so this one here, selector 3 state 1, selector 3 state 2. So state 1 will say vibrator 1 select. Okay, Control V, okay, Control V, and then state 2 is vibrator 2 select. Okay, Control C, Control V, right? So the multi-position selector switch has got vibrator number 1 select and then vibrator number 2 select. So you can use this arrangement. Okay, and then thereafter we're talking about the local stop, remote stop, local start, remote start, okay, as normal inputs. So as inputs go in this, on this panel for the vibrators, we don't need the reset push button, okay. So we don't need the reset push button, and in this first line we don't need the emergency push button. So maybe we can move this to, problem if I don't get the angle right, it's going to give us some attitude, okay. So one stop push button, the next push button, one start push button, okay, maybe something like this, okay. So we can come in for a closer look. So we've got start push button 1, start push button 2, stop push button 1, stop push button 2, and these we're going to assign to vibrator 1, local stop, and then vibrator 1, remote stop. So Control C. So local stop we may want to associate with this push button, and then remote stop we may want to associate with this push button, okay. And then we have the remote local start and remote start. So local start is this symbolic name. We need to come here as the local start, then this other address for the remote start, okay. This is the remote start, like so. And then thereafter we're talking about vibrator 1 feedback. So vibrator 1 feedback, we can just as well use this one here, okay. This one is this one here. Control C, Control V. Let's check if it's alternate. Okay, it's alternate action, which is fine. And then what do we have? We've done all the input mapping, so we don't need this stop push button, we don't need this reset. And then thereafter we go to protection, okay. So for protection we just need 1, 2, 3, 4, 5 and 6 protection inputs, okay. So we just need 6 protection inputs. So do we need these other points? Nope. So we need 6. So let's get rid of that one. So 1, 2, 3, 4, 5 and 6 protection inputs. 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. So we don't need this, we don't need that, we don't need this, we don't need that, okay. So the first one is going to be 4AE2, okay. Control C. So 4AE2 followed by 4AE3. For AE3, then for AE4, for AE4, then powder switch, okay. Control C, Control V, then of course vibrator 1, motor 1, isolators. So we're talking about the 2 isolators. Control C, Control V, and then the next isolator for vibrator 1, motor 2, is going to come here. Done. So we've done all the protection inputs for vibrator number 1, and there comes the vibrator number 1 output mapping. Okay, so the outputs should be the last line right about here at the very bottom. At the very bottom here. Okay, and we're using indicator lights for this. Okay, so what we have is we've got vibrator 1 powder switch operated. So Control C, or rather copy, we just use the red indicator lamp for the powder switch operated. Okay, and then for AC1 as a running indicator for vibrator number 1, Control C, we use a red pilot light, okay, which is this one here. That's for AC1, and then the faulted state for vibrator number 1 is for AH1. So Control C, we associate it to the yellow indicator light. Okay, Control V, like so. I think that's just about all we need. That's all we need. Now we have one excess indicator lamp. We're not going to use vibrator number 1 running for the same reason as stated before. These are just indicator lamps. So if 4AC1 comes on, it's as good as having this pilot light for vibrator number 1 running coming on. So we won't get into that. Okay, so we get rid of all of these. Now this arrangement, maybe let's see, can we move these a bit down? Now it's just cosmetic, we'll leave it like this. The arrangement for vibrator number 1 is exactly the same as for vibrator number 2, okay, except the panel for vibrator number 2 is not going to have the selector switch. Okay, so I'm just going to copy this same one. I'm going to get rid of the selector switch, and then, like previously, we're going to talk about the vibrator 1 local stop, and then of course the remote stop. Okay, so the first one is vibrator 2 local stop. So which is this one here. Then of course we've got the remote stop. Thereafter we've got the remote, or rather the local start. Okay, vibrator 2 local start. And then vibrator 2 remote start. Then what do we have? We have vibro 2 feedback. Okay, vibrator 2 feedback. We got this one here. Control C, Control V, and then talking about the mapping for protection input. So this has to be the second line, right? So we have the first protection input as vibrator to earth leakage protection. So we're going to copy this. Let's open. I need to turn it so that you're able to see what's happening. Okay. Then the next protection input. Third protection input. Fourth protection input. Fourth protection input, which is this one here. Then the fifth protection input. 1, 2, 3. 1, 2, 3, 4. Fifth protection input is this one here. Then the sixth protection input is this one here. So that takes care of the protection inputs, right? And then thereafter we're talking about the vibrator number 2 output mapping, similar to what we said previously. Okay, similar to what we said previously. The first one was supposedly the powder switch. Okay, Control C. And then vibrator number 2 on by way of 4BC1. On, it's this one here. And then the faulted state for vibrator number 2, so which is 4BH1, which is like so. So that takes care of the assignment. Okay, so maybe I need to save. Then thereafter comes the interesting part. Okay, there's really nothing special about this now. Okay, so the only other thing we need to do is go into configuration, drivers, configuration, which is here. That's under .281 is Q5.0. okay, 281. Oh, come on. Needs to number of Boolean outputs. Let's go to 16. Okay, 281 Q5.0. So 281 Q5.0. Okay, and then 2H1 Q5.1. okay, Q5.1, like so. So this takes care of what we have here. Okay, so in as far as the outputs are concerned, we've done 4DC1, 2AD1, or rather we've done 4DC1, we've done 4DH1, 2AD1, 2AH1. okay, that's what we've done here. 4DC1, 4DH1, 2AD1, 2AH1. Now the address have to be aligned to the addresses in step 7, because when you see that the pre-start warning siren was mapped to Q4.0, which is what we have, Q4.0 pre-start warning siren, and then 4DC1 is mapped to Q4.2. So Q4.2 in step 7 is Q4.2 in FactoryIO. Then 4DH1 has been mapped to Q4.3 in FactoryIO, and then in step 7 it's assigned to Q4.3. So same addressing. Okay. Then 2AD1 is mapped to Q5.0. Okay, 2AD1, and 2AH1 is mapped to Q5.1. So that takes care of the mapping for the lubrication system and the main drive. So now we go to the hydroset. Okay, so the hydroset raise is assigned to input 2.4. Okay, so hydroset raise input 2.4, then hydroset lower input 2.5. so hydroset lower input 2.5, and then what else do we have? Hydroset alarm cancel. Okay, HAC is mapped to input 3.6. okay, that's a long shot. Why the jump? Okay, maybe because all the inputs were used. So hydroset alarm cancel is mapped to input 3.6, which is right here. Okay, and then for the protection inputs, hydroset pressure switch HPSW is mapped to input 6.5. HPSW, let's see. Hydroset pressure switch, the address of which is input 6.5. Address is 6.5. Address is 6.5. For the hydroset pressure switch is input 6.5, which is right here, 6.5, and then 4CE3 is mapped to input 6.6. okay, so 4CE3 is mapped to input 6.6. 4CE2 is mapped to input 6.7. Input 6.7, which is this one here. And then for the outputs, okay, for the outputs we've got 4CC1, which is mapped to Q5.3. 4CC1 Q5.3 as 4CC1 mapped to Q5.3, and then 4CC2 mapped to Q5.4, like so. And thereafter SVC is mapped to Q5.7. SVC Q5.7, like so. And then then what else do we need? 4CH1 is mapped to Q5.5. 4CH1 is mapped to Q5.5. And then we're not mapping the hydroset on, right? Then HLPS is mapped to Q7.0, so we need more outputs apparently. So Boolean outputs, do we move to 25 so that we don't have to be doing the same thing? that moves on to 7, 25, maybe 40. Okay, so 4CH1 is mapped to Q5.5, and then hydroset pressure switch HLPS is mapped to Q7.0. HLPS is mapped to Q7.0. So the hydroset low pressure siren is mapped to Q7.0, which is this address here. Okay, and then thereafter hydroset OK, HDR OK, HDR FLT. So HDR OK is mapped to Q7.1. Okay, Q7.1, and then HDR fault is mapped to Q7.2, like so. Takes care of this, and then we move on to the vibrators. Okay, we move on to vibrator number 1. So vibrator 1 select. Vibrator number 1 select should be mapped to input 8.4. Apparently, okay, so we need to increase the number of inputs. I have to go Boolean inputs. How many do we need? Maybe let's move to 70. Lost connection. Are you running? Boolean inputs. Okay, let's see how far we've gotten. Okay, so where are we? So we're saying vibrator 1 select is mapped to input 8.4. So vibrator 1 select is mapped to input 8.4, and then vibrator number 1 local stop as by way of 4AB7. Okay, so 4AB7 4AB7 001 4AB7 001 is mapped to input 2.6. okay, 4AB7 001 4AB7 001 is mapped to input 2.6, and then 4AB7 002 is mapped to input 2.7. 4AB7 002 is mapped to input 2.7, like so. And then 4AB8 and 001 and 4AB8 002 are mapped to input 3.0 and input 3.1. So 4AB8 is mapped to input 3.0, 4AB8 001 input 3.0, 4AB8 002 is mapped to input 3.1, like so. So I've taken care of local start, remote start, and then vibrator 1 feedback. Okay, this one here, V1 feedback, vibrator 1 feedback. Vibrator 1 feedback is mapped to input 8.6. Okay, vibrator 1 feedback is mapped to input 8.6. This one here. Okay, vibrator 1 feedback is mapped to input 8.6, which is what we have done here, right? I think we're right. And then I think we're done for vibrator 1 input mapping. Okay, then normal inputs, that is, then vibrator number 1 protection input mapping, we've got 4AE2, which is mapped to input 7.0. 4AE2 is mapped to input 7.0, so 4AE2 mapped to input 7.0. 4AE3 is mapped to input 7.1. Then 4AE4 7.2, and then vibrator 1 powder switch is mapped to input 7.3. So vibrator 1 powder switch, vibrator 1 powder switch is mapped to input 7.3, and then vibrator 1 motor 1 isolator is mapped to 7.4. So vibrator 1 motor 1 isolator is mapped to input 7.4. Vibrator 1 motor 2 isolator is mapped to input 7.5. Okay, and then for the output mapping for vibrator number 1, we have the vibrator 1 powder switch operated. So let's see, vibrator 1 powder switch operated indication is mapped to Q6.0. Is mapped to Q6.0. And then of course we have 4AC1, which is mapped to Q6.1. okay, 4AC1 which is mapped to Q6.1, like so. And thereafter the faulted indication 4AH1 is mapped to Q6.2, and then what else do we have? We never mapped vibrator number 1 running, so it's not really an issue. Okay, then we move on to vibrator number 2 mapping. Okay, so vibrator number 2 input mapping, we've already dealt with vibrator 2 select. So this is supposed to be mapped to input 8.5. okay, so input 8.5 should be vibrator number 2 select. Okay, and then the local stop, remote stop by way of 4BB7. So 4BB7 meaning 4BB7 001, 4BB7 002, 4BB7 001, 4BB7 002, which are these two. 4BB7 001, 4BB7 002 will be mapped to input 3.2 and input 3.3. So 4BB7 001, so we're talking about 4BB7 001 3.2, 4BB7 002 as an input 3.3. So 4BB7 001 as input 3.2 and 4BB7 002 as input 3.3. Then 4BB8 001 and 4BB8 002 as input 3.4 and 3.5. Okay, so input 3.4 and input 3.5. okay, I think I've messed something up. So what's input 3.6? Input 3.6 is what? HSC, how to set alarm cancel. Okay. .6 is HSC. Okay. So we've done local start, remote start, local stop, remote stop. So the only other thing we need to do is vibrator 2 feedback, okay, which is going to be mapped to input 8.7. So vibrator 2 to feedback, which is going to be mapped to input 8.7, like so, which takes care of the normal input mapping for vibrator number 2. So we move on to protection input mapping. So 4BE2 is going to be mapped to input 7.6. okay, so 4BE2, which is this one here, is going to be mapped to input 7.6. What am I doing? 7.6, 4BE2, vibrator 1, motor 2, input, vibrator 1, motor 2, isolator, vibrator 1, motor 2, isolator is 7.5. okay, then 4BE2, which is this 4BE2, is input 7.6. okay, then 4BE3 is input 7.7. then 4BE4 is input 8.0. then 4CE2, not yet. Why is 4CE2 an issue? 4BE4, this is 4BE4. okay, let's look at something. What's 4CE2? .4CE2 is input 6.7, which is already taken care of as 4CE2 as input 6.7, okay, which is this one here. So the only thing we need now is okay, 4BE4 has input 8.0. then vibrator 2 powder switch is mapped to 8.1. okay, vibrator 2 PSW is mapped to input 8.1. so vibrator 2 powder switch, which is this one here, vibrator 2 powder switch is mapped to input 8.1. and then vibrator 2 motor 1 isolator is mapped to 8.2. vibrator 2 motor 1 is mapped to 8.2, input 8.2. vibrator 2 motor 2 is mapped to input 8.3. vibrator 2 motor 2 isolator is mapped to input 8.3. and then for the output mapping, we're going to have vibrator 2 powder switch operated being mapped to Q6.4. okay, so vibrator 2 which is vibrator 2 powder switch operated indicator, is going to be mapped to Q6.4. So Q6.4, and then 4BC1 is mapped to Q6.5. 4BC1 is mapped to Q6.5, and then 4BH1 Q6.6. 4BH1 Q6.6, and then I think that's just about it. I think that's pretty much the only thing we need to care about. So perhaps for now we can just save this. Then what else do we need? We need to determine the normal state. Okay, what I mean is, if you look at the feedback signals, okay, I know that all the protection inputs are supposed to be fed to the PLC as true signal states. Under normal conditions, these signal states are supposed to be true, so I've got no issue with these. Okay, I've got no issues with any of the protection inputs. But what I do have an issue with is the issue of the flow. Okay, for the flow, we need to come into FactoryIO and actuate the push patterns to simulate a feedback of flow, right? But for feedback, like vibrator 1 feedback, vibrator number 2 feedback, these are not true states. So meaning at some point we need to actuate these. So let's see. So I'm sure the one which is on is the, how to say it, low pressure switch. Okay, so I just wanted us to see that these indicator lamps are on, right? So we've got vibrator 2, powder switch operated indicator, and then 4BH1. But the 4BH1 has a 4-day state for this vibrator, right? And I think that's on account of the operation of the powder switch, I think. So just to help us understand something here. Okay. So 4BE2 and 4BE3 will be right about okay, so we're using all the protection inputs as normally closed true states. Okay, then 4BE3 4BE3 4BE3, why would 4BE3 not be true? So 4BE3, okay, so 4BE3 is okay now. And then what else do we need? So basically I'm looking out for the state that all the protection inputs are supposed to be true. Okay, and then for us to be able to start, the powder switch operation should be false. Okay, so vibrator 2 powder switch operated and vibrator 1 powder switch operated, these are basically true. But if you remember previously, what we said was the powder switches were only operated at a point where the crusher is running, all the material is being crushed, and the stockpile reaches stockpile. Essentially what I mean is the material is piled up to such a level that it actuates or activates the powder switch. That's when you expect the powder switch operated indicator lamp to be true. Okay, So basically this is how we were validating our inputs, and I hope you do remember what it is we're doing. Okay, so we went as far as talking about protection inputs, right? We went as far as talking about protection inputs as it relates to validation. So let's see. So output mapping, hydroset mapping. Okay, so previously, if you remember, we assigned the inputs to bits in the memory word, where we started with memory word 1000 as assignable bits to whatever inputs we're getting externally. Okay, and then of course we also had memory word 2000 as the one which now passed the signal states to the memory bits in our logic. Okay, so what I mean by this is this. Okay, if you look at this, okay, so essentially what we're doing is the first memory bit was what? So memory bit 1000.0. okay, so you notice that whatever input we're getting as a peripheral input signal. So if we're getting this signal to the PLC or to a simulator by way of input 5.0, our logic basically is using memory bits. Okay, so we need to pass that signal state of this physical address passed to a memory bit address. Okay, and then this memory bit address is subjected to a whole checklist of condition, and then the output of memory bit 1000.0 is passed to memory bit 2000.0, which then passes its signal state to our memory bit, the actual memory bit which is in the logic. The reason why we did this, we said we wanted to be aware of the transitions in the inputs, the transition in the input signals. So based on the same understanding, you notice that we went as far as memory bit 1000.1, we went as far as memory bit 1000.4, memory bit 1000.6, memory bit input 1001.2. okay, but the thing we have to be mindful about is the fact that this memory word only goes as far as memory word 1001.7. we're already playing with 1001.2. so what I'm going to do is this. Okay, what I'm going to do is this. It's basically the same understanding. Okay, so I'm going to copy this and then I'm going to paste it. I'm going to paste it here. Okay, paste. And then what I'm going to do is I'm going to do an extension of this. We're going to start from memory word 1010. Okay, so memory word 1010. Okay, like so. And then the result of this is memory word 1012. Okay, so this is going to be passed to this, and then the output is memory word 1014, the result of which is passed to the next block, and then the output, okay, as memory word 1000, or rather memory word 2002. Okay, so this here is the same as that. So this gives us an additional 16 bits to play with. Okay, so this was meant to just illustrate the operation of the bits, which you can refer to the previous video. Okay, and then I'm going to insert. I could have used a memory double word and helped myself with 32 bits, but I think I would rather do it like this. Okay, so again, we're not going to change anything with memory word 1002, and we're not going to change anything with memory word 1008, because this is a status memory word and then memory word 1008 is a reset memory word. Okay, so that's why we're not touching them. So now the farthest memory word address was 1014. Okay, so memory word 1016, memory word 1016, 1018, which is going to be passed to this one here, and then memory word 1020, which is going to be passed to this position, and then memory word 2004. Okay, like so. Okay, and then maybe, okay, so what, right about 32, and I think that should be enough. Okay, so this should be enough. So Windows, so now we have this. So now this is just about mapping. So for the first part, I could even do this. So we can say loop system, you can say lubrication system, and crusher main drive mapping. Okay, like so, mapping. Okay, which is whatever addresses are in this are associated with this function, and then this one will be hydroset mapping, or so we can say input validation. Okay, and then hydroset input validation. Okay, so I've got hydroset input validation, and then we've got vibrator. Okay, input validation, like so. Okay, so now we have these. So when this is done, we'll go to, what do we have? Protection input. We'll go to hydroset. Okay, we'll go to the hydroset. Okay, so basically the input validation has to do with the protection input mapping. Okay, we need to validate the protection input mapping, not the operational conditions. So we start by way of doing the following. Okay, we're going to pass the state of the hydroset pressure switch from FactoryIO. This signal is coming from FactoryIO, but we need to pass it to a signal, or rather to a bit which is being subjected to these logical conditions. So the first bit in this memory word will be memory bit 1010.0. okay, and then the first bit in the output memory word is the following, that memory bit 2002.0, which is then going to pass its signal state to the hydroset pressure switch memory bit, which is used in our logic. Okay, and then of course we move on, we do the same thing for the second input, that this is going to be passed to memory bit 1010.1, and then memory bit 2002.1 will pass its signal state to 4CE3, and then we're going to have the FactoryIO input signal 6.7 passing its signal state to memory bit 1010.2, and the memory bit 2002.2 passing its signal state to 4CE2. Okay, so basically this qualifies the input validation for the hydro set. In as much as we've got all those 16 bits, we've only used like 3 of each memory word. Okay, then we go to vibrators. Okay, or maybe what we can do is we can say vibrator 1 input validation. Okay, let's copy this, paste here. Okay, and then here we can say vibrator 2 input validation. So ramping up the addressing, we went as far as memory word 2020. So looping around, we have memory bit 2022, and then 2024, which is the same there, paste there, and then this is going to be 2026, which is going to be pasted here, and then the output memory word will be 2006. Okay, like so, right? So let me just save this. Oh, am I right? Am I right or am I right? 2020, 1020, 1020, 1020, and then thereafter 1022, 1024, 1024, 1026, 1026, 2006. So 2004, 2006. Okay, so we've done the hydro set input validation. So we can go to the vibrator 1 protection input validation. It's the same process. Okay, so this is vibrator 1 input validation. The memory word is memory word 1016. Okay, so the first bit in that memory word is memory bit 1016.0. okay, and on the output side the first memory bit is memory bit 2004.0. okay, which is going to pass its signal state to 4AE2. So that takes care of the first part. Okay, and then 4AE3 will get memory bit and memory bit 1016.1, and then memory bit 2004.1, passing a signal state to 4AE3. okay, like that. And then this other one, we have 4AE4 by way of input 7.2, passing a signal state to memory bit 1016.2, and memory bit 2004.2, passing a signal state to 4AE4, which is the memory bit used in our logic. Okay, likewise, this is memory bit 1016.3, getting the signal state of input 7.3, and then memory bit 2004.3, passing a signal state to vibrator 1, number 1 paddle switch. Okay, and then we have this input passing a signal state to memory bit 1016.4, and then memory bit 2004.4, passing a signal state to memory bit 22.4. okay, then here we have input 7.5, passing its signal state to memory bit 1016.5, and then memory bit 2004.5 passing a signal state to memory bit 22.5. okay, so I think this pretty much does it. And then we go to vibrator 2 protection input mapping. Okay, for vibrator 2 input validation, the first memory bit is memory bit 1022.0. okay, so input 7.6 is going to pass its signal state to memory bit 1022.0, and then memory bit 2006.0 is going to pass its signal state to 4BE2, memory bit 22.6, which is what we've used in our logic. And based on the same reasoning, the same reasoning basically applies. Okay, so this is that 4BE3. This is what? This is 2. That is 3. That is 4. It is 5. I've shown you the way this has been done. I just want to quicken up the process. Okay, so this is remember 2. Okay, so same thing. I'm really not doing anything extraordinary. The ceiling contact, this is memory word 2000, this is 2002, sealing in through this point, and we need to do the same thing for this point. Okay, we'll copy this, paste there, so that we seal in. Okay, so basically this is taken back to seal in the logic. Okay, so 2002, 2002, 2000, 2000, 2004, 2004, 2006, 2006. I think this pretty much takes care of our little ghost in the shell. Okay, so vibrator number 1 powder switch is this one here. Okay, so, and then of course we need to do a system reset to normalize the signal state. Okay, so vibrator number 1, vibrator number 1 powder switch. So, and then if we do a system reset, okay, so now we're getting the expected behavior. Okay, so if the powder switch is operated for vibrator number 1, okay, so if we operate the powder switch, we expect there to be a transition in the output bit used in the logic by way of memory bit 22.4, right? So the was that here? Okay, we're focusing on this section here. You notice that the signal state of the powder switch from FactoryIO is true, but the bit status in our logic by way of memory bit 22.3 is false. Okay, so if we actuate the input simulation, this becomes true, this becomes false. Okay, even if we normalize this, the default state is maintained, so we need to do a system reset. Okay, so we need to do a system reset to normalize the bit condition. Let's look at the powder switch to thermal overload powder switch. So this is okay now, because now the powder switch operated signal state is not on, which is what we expect to be the normal status of operation. Okay, so going back to FactoryIO, what else do we need to check? So drivers. Okay, let's see. So the hydroset is okay, so meaning the hydroset pressure is okay, so we should be able to start. And then if we actuate the hydroset pressure switch, we expect the system to get into a faulted state. So we are toggled the alarm cancel for the hydroset, so this is normal. And then the hydroset pressure is okay, we can say hydroset raise. Okay, so the solenoid valve is on and the CC1 is also energized, so hydroset lower. Okay, so this seems to be working okay. And then what else do we need? We wanted to check the, I don't know, so let's see. So that's working okay. So the other thing we needed to check for us to start was the feedback. Okay, by way of V1 feedback and V2 feedback. And then don't we have another feedback input? I'm sure it has to do with the loop test input. Then so what do we have? H5A, vibrator 1 feedback, vibrator 2 feedback. What else do we need in terms of feedback? Apparently that's all there is. Main drive. I thought the main drive also had a feedback signal. 281. So we don't have 281 feedback, and we don't have the let's see, 281, okay, and then 4DC1. So we need 281 feedback and we need 4DC1 feedback. So for the most part, I'm just going to copy this. I'm going to copy this one here. Okay. And then, of course, this is going to be $281 feedback, 281 feedback, and 4DC1 feedback. Okay. So this is it. So 281 feedback, 4DC1 feedback, and we need to go to input-output mapping. So let's see, window options, symbol table. We're looking for 4DC1 feedback. So 281 feedback, 481 feedback, 281 feedback, 4DC1 feedback. So on inputs, okay, so basically I need to map this to just normal inputs. Okay, I just need to map this to normal inputs. Okay, so normal inputs it is. So we're saying we need these two, and externally for input addresses we went as far as those are outputs. So we went as far as input 8.7. so we need to insert two of these. Insert symbol, okay, and then we need 281. We need this in that position as a peripheral input. Okay, like so. And then of course this one here, and this address is going to be passed to this one here. Okay, as always, inverted commas to, just put them in inverted commas. Okay, and then of course okay, so 4DC1 peripheral input. 4DC1 feedback. There's a peripheral input. Okay, maybe that's where my problem was. I didn't put the dash there. Okay, so that takes care of this. So for 281 feedback and 4DC1 feedback, 9.0 and 9.1. So 9.0 and 9.1. And 9.1. 281 feedback and 4DC1. Okay, like that. Okay, file save. So now if you look at vibrator 2 feedback, and then you also look at vibrator 1 feedback, okay, these are already true states. Okay, so if I came into FactoryIO, and then went to the vibrator 1 panel, okay, the starter panel, like so. For the feedback, okay, I'm basically talking about this push button. Look at the state of this. If I press, there's no feedback. If I press this, there's already feedback. But if you look at the part where we use the emergency push buttons for feedback, for the feedback signal, right? So we'll go to where it says the 281 feedback and 4DC1 feedback, which is in this state, okay, which is the last two states. These are already true. So if I have to simulate a failure of feedback, I just need to press this. Okay, so either can work, but we just need to know how to use them. But for uniformity, we could have used the reset push buttons. So the same thing for the flow. Okay, when the system starts, we need to come to the operator panel for the lubrication system and the crusher main drive to simulate a flow, okay, to simulate a feedback or to simulate a flow in the system by pressing this push button, flow 0101 and then flow 0201. We need to come and press this to simulate that there's actually a flow. Okay, so that's where we're at with the whole system, like that. So to go through the next step, now that we have pretty much set the background against which we're going to later simulate the system, we're going to end here so that next time we just get straight into simulating the operation of the system. Okay, ciao.